And so the agenda today, I've got some pictures in here just from trips I've taken in doing research for my model railroad. This is actually the paper mill in Niagara, Wisconsin, and I modeled that. But anyway, the agenda today is I'll tell you a little bit about me and my railroad, talk about the project objectives, what I set out to do with the turnout control and everything, and then some of the things that I've learned over the course of deploying all this, what the system requirements are, some of the technical details for some of the products that are required in the way I do it. There's many ways to do this. And then a little bit about how I handle layout wiring, because I think that's a little bit different. Also, the way that I build scratch-built control panels. I've seen a lot that look kind of like mine. Followed by pound. Somebody's on hold or something. But anyway, then the last thing is I'm going to take us from the beginning to the end of the process to make one connection. Let's see here.
You are in the meeting now.
Oh, good. You're in the meeting. All right, good. We'll keep going.
This meeting is being recorded.
I am in the meeting.
All right, wonderful. Welcome. So, so that's the agenda, and we'll get right to it. And I think we'll probably be about 30, 40 minutes with this, but we'll see how we do. So first of all, a little about me. I'm Greg Biltman. I live in Gary, Indiana. I spent most of my life. Thank you. I spent most of my life in Libertyville, Illinois. My passions are listed there. I left out whiskey and cheap or fast women, but I'm a church musician. I'm also a professional musician and composer. I work in the technology field, and I've studied leadership. I'm into old vintage vans and, of course, trains. I do have a Bachelor of Music degree, also a Master of Science in School Administration, and I pursued my doctorate back in the 90s. And then when I went into technology, it didn't really make sense to write my dissertation, so I left that out. I'm not an electrician. I do electrical work around the house and stuff. And I know Neil's an expert with the LEDs and resistors and all that stuff. I managed to make that stuff work, but I'm not an expert on that. My dad was a computer programmer. I did a little programming back but not really a computer programmer. And I do expect that I'll probably learn as much as we go through this. And certainly in preparing for it, I learned a few more things. So if you see something that I'm talking about and you think, well, you're kind of going around the long way around the block on that, but be sure to speak up and I'll make a note of that, and that'll be helpful to me. And I won't be offended in the least. So my model railroad models the ore country up in the Upper Peninsula on the Menominee Range. And it's, I model the joint operations. Whoops, this thing has got a mind of its own. I model the joint operations between the Chicago Northwestern and the Milwaukee Road up in the, really from Iron Mountain to Escanaba. So that's what I'm working on. What I hope to accomplish with this is to basically enable all the turnouts on the layout to be controlled by JMRI and from multiple locations on the layout. So that was kind of what I started with. I wanted to be able to use push buttons instead. I had been using toggle switches, but a toggle switch doesn't work so well if you're controlling a turnout from two different spots. So went to the push buttons. And I wanted to be able to, you know, as I got going on this, I needed to make the cabling a little better organized. So that's where the Ethernet stuff comes in. And then I found it a lot easier to build these control panels at the workbench. So I came up with a way for them to be modular so you could separate them. And then I wanted to be able, in the future, to be able to run trains automatically just from JMRI. So I'm not ready to do that yet, but I haven't painted myself into a corner where I can't do that yet. So. As far as system requirements go, you're going to need, there's many ways to do this, but the way I do it, you definitely need to be using JMRI, and I'll talk a little bit more about each of these components. And you're going to need to connect a computer to the layout, and I use a DIGITRAX PR3 for that. You also need a stationary decoder. I think I used the wrong form of stationary there, but I'll fix that later. So I use DS64s for that. You need a slow motion. Really, you don't need a slow motion switch machine. I guess you can use any switch machine, but I use tortoises. And then if you want to use these physical panels, then you got to build those. The Ethernet section, I've got all the materials needed for that as well, listed later. And then all the little electrical components, the plexiglass, I forgot to put styrene in there, but I use that as well. So at a high level, that's kind of what we'll be talking about and what you need from a technical standpoint. So PR3 is basically the decoder programmer, and it serves as an interface via USB to a computer. And I've kind of made the assumption that we are using a computer. I didn't put that on the list of things, but you do need a computer. And JMRI can run on anything, but if you're using DIGITRAX, then you're pretty much limited to either Mac or PC. The PR3 is useful for a lot of other things. It allows you to program the various decoders, put sounds on the soundtrack stuff and all that. So it's a very useful device. The PR3 itself is no longer available from DIGITRAX. It's been, the new version is a PR4. I've never seen a PR4 yet, but I'm sure it's basically the same thing. So the stationary decoder looks a lot like a PR3, just different electronics inside it. It's pretty easy to work with. You need one of these for every 4 turnouts. Now, of course, if you're using tortoises, you know, there's a kit that you can buy to connect 2 tortoises to control a crossover or something like that. So in that case, you could, you know, if you had 4 of those, you could connect 8 turnouts. But anyway, the DS64 will operate 4 turnouts, and it has up to 8 inputs that you can configure. And I'll be talking about how you do that. Everybody, I think, probably knows what a CIRCUITRON tortoise looks like. There it is in living color. So I wound up very early in my like probably 15 years ago, 20 years ago, when I first started doing this again after I picked it up from being a kid. I went to an estate sale where somebody was selling about 25 tortoise machines that I got for a couple bucks a piece or something like that. So that made the decision easy that I was going to use tortoise machines. So I have many tortoise machines on my layout. Every turnout is controlled by a tortoise. So the Java Model Railroad interface is open source software. You can download it. There's a link in the presentation, which I'll distribute after the program. It's pretty easy to set up. For me, I do computer stuff all the time. I'm not really, I'm not a super user on the computer or anything like that anymore. My job requirements are more executive oriented, and so I am kind of a normal computer user, I guess I would say, maybe like 3/4 of the way up or something like that, and I have no problem. But you know, it is open source. It's well documented, and it can be a little tricky, but I managed to get through. There are several different components. We talked back in February, I guess it was, about Operations Pro, and I'm very eager to get going on that. I haven't started using that yet, but there's several different components that you can use. We're going to focus here today on Panel Pro. That's what you use for this layout control stuff. But it has a lot of uses. It'll run on just about anything, as I mentioned before. So Panel Pro is the component that we're talking about today. There's 4 different editors, and they all work a little different, but they all use the same information. So Layout Editor for me was the easy place to start, and you can consult the documentation for all the details, but with Layout Editor, you can basically snap together these track sections and stuff and create either a schematic or an actual kind of diagram that resembles the physical layout of your railroad. And then those components can be linked through the software and all these interfaces that we've been talking about to actually control turnouts and other things on the layout. So that's where I started, and pretty much what I used most of the time. I did a little work with Control Panel Editor. The panel editor allows you to create these virtual CTC machines. They're beautiful, and they have all the graphics to allow you to snap all that together. And so I know some people on the call probably have done that. They're really neat. And then there's a switchboard editor. I haven't worked with that, so I'm not sure what that is, but they all, you know, the data behind all of that is all the same. It's really just several different ways to actually work with the interface. So it was really helpful for me to learn how JMRI works to use Panel Pro. Now that I have the physical panels in place, I think I've built 5 or 6 of them so far. I've got 4 or 5 more to build. I pretty much use Panel Pro just for configuring everything and then troubleshooting. So, but it's a great piece of software. So those are the components. That's, you know, from a technical standpoint, that's what you're up against. One of the things with all the many turnouts and decoders, I think I have 8 or 9 DS64s deployed. You know, you're going to have a lot of wiring to deal with. And so here's a picture of the first one that I deployed with doorbell wire. And obviously it became a massive mess, rat's nest. And so I needed to figure out a way to avoid that. And I'm sure we've all figured out our own ways to do that. Doing this, you've got at least 6 wires going to each turnout, or, you know, for each circuit. So, you know, just stringing that across the bottom of the layout. I mean, that I have since replaced that rat's nest that I just showed you, but it worked. I mean, it didn't have any reliability problems or anything. It was just ugly. So I am in the networking field, so I've got Ethernet cable all over the place. And so I started using Ethernet cable because it's basically 8 strands of hookup wire within that jacket. And so it made it real easy to route wire everywhere and group those up. So that also then led to where I started using the patch panel components in order to make it modular, so I could take the panels off the layout and work on them on the workbench. So these Ethernet patch panels are relatively inexpensive if you buy them used. And I take them apart into these little, I don't know what they're called, but they're little sections that have 6 connections each. And I just use those as the interface for a physical panel. And I'll show you how I did that a little later. But it actually works real well, and it's neater now under the layout. It's not necessarily a shining example of documentation and neat wiring, but it's better. This is a panel that has been wired, and you can see in the lower right-hand corner, the patch panels are there, but this is how I do the wiring on the back. So I'm wiring to all the push buttons and LEDs. And then, of course, you got to document where everything's going so you know where to wire it later. But just as an example, the rat's nest that I showed earlier was for a panel about 1/3 of this size. And so you can just see how much better organized and neater that is than what I started with. This is kind of what it looks like under the layout when you use that. You can see the Ethernet cable with the 2 on it is coming in there, and then you just strip it back and then connect those wires, in this case, to a DS64. And then I do use termination blocks to connect to the turnouts, because that's just a little easier. This is what the patch panel looks like under the layout. I just stuck my phone under the layout and took a picture of that the other day when I was preparing for this. And here's what it looks like to kind of remove one or install one. You can see you just kind of pull the thing out of the hole, and then the wires, the actual Ethernet cables that are connected to all the components on the layout are inside of there. They're labeled, so take it out, go do whatever work you're going to do. I mean, I did go to a lot of trouble to do it this way, and frankly, I haven't had to do a lot of work once I deploy them, but it does make them a lot easier to deploy anyway. So to do this, as far as what you'll need, you're going to need Ethernet cable. We're not using it to support any protocol or anything, or to transmit data really. So it doesn't matter what you can get. You can buy the cheapest stuff you can find. You will want to get an Ethernet crimper so you can make your own cables and crimp the ends, you know, and have them custom length. So and then you'll need a bunch of RJ45 plugs. So I don't know how many people make their own LocoNet cables, but I do that as well. It's basically the same thing. The LocoNet's a different type of cable, but it's the same process. Like I said, the Ethernet patch panels, you can find them on eBay, pretty cheap, and I just take them apart and use those little sections. I'll show you a picture of that in a second. You're also going to need a punch down tool. I had a beautiful professional punch down tool that was awesome, and I have no idea where it went. So I just used one that came in a little package with a Leviton Ethernet port, and I'll show you that in a second. The other thing is just documenting where all these cables are going and stuff is going to be important. So I'll show you in a minute how I do that. And then of course you're going to need to be able to solder wires and things onto the panels themselves, and I'll go into a little more detail about that in a second. So this is what the patch panels look like when I take them out of the larger frame, and then sitting next to it is the punch down tool. That's the cheapest plastic punch down tool you can get. The other one I had was really it was made of steel, and it had blades on it, so it automatically trimmed the wire and all that. So it was a wonderful thing. Someday it'll turn up, I'm sure. This is what it looks like when you're using it, when you're actually installing the wire. I don't know if you've ever, you know, the other thing that uses this type of connection is the old telephone system, the station cabling, whatever it's called. But anyhow, you're just basically shoving that wire down onto the blade of a connection there, and it automatically shaves off the casing, and then, like I said, you don't have to, but I go in and trim the excess wire off the inside there, and actually it's off the outside. I'm showing that backwards. You would typically wire from the inside out, not the outside in, which this picture is showing. And then this is just a close-up of some of the soldering and wiring onto those switches and stuff. That can be a little fun. So I've gotten better at that and only burned my fingers a couple times with the soldering iron. So that's that. The next thing is the physical control panels themselves. And generally the approach to building these is I create a schematic of the area that I want to control. In an art program, I use Adobe Illustrator because it's designed to do vector graphics, so it's real good with lines. And I actually print the schematic 3 times. I print one version that shows where all the wiring, where all the components are, and I'll show you that, an example of that in a minute. So there's one that's kind of the guide to where everything goes, and there's one that I use while I'm drilling the holes in the panel, and then I have a clean one that I put in after everything's done, and that so it looks nice. The first ones that I did don't look as nice as the newer ones, but that's probably a good thing. I'm getting better at it. I'll show you an example of what I call a connection matrix, which is where you do all the documentation to keep track of where everything's going. And then basically we're going to take a piece of plexiglass, cut it to the proper size, and a matching sheet of styrene for the back of it. And then we're going to sandwich that with the diagram and tape it up, drill it. I use a Dremel drill press to drill the holes. And then you know, you take it back apart, put a fresh piece of fresh diagram in there, cut the holes in the paper, and then deploy all the components onto the board, wired it up, and put it on the layout. And at that point, then that's when I wire all the Ethernet to all the DS64s and turnouts and everything, or tortoise machine. So this is obviously an eye chart, but this is what a schematic looks like for the latest one that I built, which is the biggest so far. And so all those numbers and everything correspond to addresses or you know, codes basically that I have in my documentation to know how that corresponds to the various things that are configured in JMRI. And so I use, in the software I use, you can have layers. So I have a layer where all that documentation is in one layer. And so when I print it this way, that layer is visible. I turn off the visibility for that layer, and then I've got a nice clean diagram to actually use with the physical panel. This is an example of what the diagram itself would look like, not the diagram, but the connection matrix. And the main thing is just to know, like for each cable, you've basically got 8 wires, and you're just trying to figure out, well, where do they go? And so, you know, you reason that out and design it. And the next slide is basically meant to show that it doesn't always go according to plan. The little arrows in the right-hand side show where I reversed a wire, and I wrote a note to myself at the bottom there, something I goofed up and needed to do differently. But you kind of keep track of what you're doing. The X's or the checks are all, okay, that one, you know, is complete and tested. I also have a notebook where I document all the testing and everything. So it's really easy to get. I don't always have the ability to spend a lot of time at once to just do this and get it over with like I would do at work. It's often here and there, and so I always take really careful notes because I come back and I can't remember what I was doing. So I'm sure I'm not alone in that. This is just what it looks like when we're building the physical panel itself. The Dremel drill press is very handy for this. And so basically, you know, that in this diagram, I don't have that taped up, so it looks like I've already drilled all the holes, and I decided I wanted a picture of it. So I think that's kind of, well, I haven't drilled, you need to also drill 4 holes in the corners to mount it, so I haven't done that yet. But that particular panel is pretty much complete, it looks like. That's an older picture and an older panel. This is what, yep.
Greg, do you back drill those? I typically drill from both sides when I do plexiglass.
Yeah, that's, you know, you do get a lot of burrs when you're drilling that. I've never double drilled it. What I do is I just drill it, and then I take a one-sided razor blade and just shave off the burr on the back side. But re-drilling it might be a better idea. It'd probably be cleaner.
Thank you.
That's a good point. This is what it looks like once all the holes have been drilled and you start installing the components. So this particular panel also has some three lead LEDs that are used to show whether the power is turned on to staging tracks. I'm not going to cover that today, but that's what the red, those are actually DPD, whatever, double pole, double throw switches to turn the power on and off, and then lights to show whether it's actually powered. I use glue Walther's glue to secure the LEDs. I've tried a bunch of different adhesive in there, and super glue and stuff like that would always craze the plastic on the LEDs. And so glue seemed to be the best route. The first one that I did, I tried to just stick them in there and hope that friction would hold them, and that didn't work so well. So that one still, that's the first one that I did. It's still working on the layout in its original state, but one of these days I'll replace it because the light bulbs always fall out. Very irritating. This is what that panel that I showed at the beginning, this is the latest panel I built. And so it's all lit up, and there were, I can't remember now, but I counted up how many connections were required to do that, and it was a lot. But it works perfectly, and it's just what I wanted. So very happy with it.
Very nice. Very nice.
Thank you. So the next thing, the last part here is just really taking one of these connections from start to finish and all the things that I ran into. I don't know that there's a lot that I'm presenting today for people who've already done this or that are in the middle of it that's particularly innovative or helpful. And hopefully there's some things, but there is one thing in this part of the presentation, if you haven't done this before, that is, that took me forever to figure out. And I feel like is probably the most valuable part if anybody's actually going to do it this way. So that's the teaser. The good stuff is coming. So the assumptions here are we've got an operational model railroad. We're running DIGITRAX DCC, got a booster, a throttle, everything's working perfectly. And what we're focusing on today is one, call it a left-hand turnout, doesn't matter, but one turnout that's already been deployed on the layout. A tortoise machine has been attached to it and it works perfectly. And what we're going to do today is basically connect the wiring to a physical control panel that's already also been built and deployed. So our first objective is we're going to make sure we can control the turnout with the tortoise machine connected to a push button. And then the second thing we'll do is add the lights to that circuit to so that we can see the status of the turnout on the physical panel. I do it that way for this training purposes because the LED thing, if you start with that, there's a couple of things that can go wrong and it can wind up costing you a lot of time. So I just feel like when I got started, the first thing was just keep it simple. Try to control the turnout. Once you get that working, then putting the lights onto that circuit is pretty easy. At a high level, what we're going to do is first we're going to connect the PR3 to the layout, configure it, make sure it's working. Then we're going to connect one DS64 to the layout and configure it in JMRI. The next thing we have to do is basically connect the DS64 to the tortoise and test that, make sure it's working. Then we're going to connect the push button to an input on the DS64, and that will in turn allow us to control that tortoise from the push button. After that, we'll add bicolor LEDs to those circuits to show the status, and that is really no different than just allowing the tortoise to basically give us feedback as to its state. You know, that's something that you can use the tortoise for, and is documented in their instructions. Then we're going to go in JMRI and configure a route. In our case, the route is just going to be a very simple toggle of that turnout, and then we're going to push the button if we get it right. Being asked if I want to upgrade my account. So we got 10 minutes. We're doing great. Perfect. Anyway, you push the button, and if you hear the tortoise machine move, then you know you're halfway there. So the first thing is connect the PR3 to the layout, configure it. So there's great documentation for JMRI. You can also download documentation for the PR3, your interface from DIGITRAX. On Windows, you may have to deal with drivers if you're using an old version of Windows, and that is documented as well. In JMRI, and I'll show you a screenshot of this, you're going to select the PR3 and connect it to a serial port. And so that can be a little bit tricky, but it is well documented, as I mentioned, and I'll show you the pictures here to show how it works. You do have the option of using the PR3 as a command station, but if you already have a booster, it's a better idea to have the booster be the command station. And so you need to configure that, you save everything and restart. There's a million ways to do this, and there's a lot of folks on the internet that have answered questions and posted things about how they do it. So there's a wealth of information out there, but this is how I did it, and it works. So here's what it kind of looks like from a block diagram. You've got JMRI running on either a Mac or Windows in this case, because we're using DIGITRAX. That's connected by USB to that PR3, which is connected via LocoNet to your command station or your booster. And then that's going to be connected to your railroad. So that's basically what the connections look like. The screenshots, this is what it looks like when you're configuring the PR3 in JMRI. And so, you know, you'll just choose which manufacturer you're using. It's going to be a LocoNet connection in this case, and then you're going to map a serial port to that USB port. I did this so long ago, I can't remember what went wrong, but I did have to do it a couple of times before I got it right. And the other thing in JMRI is that you definitely have to remember to save regularly. It's very it's very easy to neglect that in JMRI, especially these days when a lot of things seem to save everything automatically, and so that's just a little word to the wise if you haven't used JMRI a lot. So the next thing is to connect the DS64 and configure that. So great documentation for both of those things, and these are links. So if you're viewing this as a PDF or as a PowerPoint, you'll be able to click and just get straight to the documentation there. It is much easier to configure a DS64 using JMRI than it is following the instructions from DIGITRAX and using a throttle. So that's why I do it this way. You do have to set the board ID using a throttle. Once you've done that, you can use a throttle or use JMRI to configure the other aspects and options. When you're doing more than one DS64, what you can do, the settings are, in my case, everything's uniform on the railroad. I'm using the same configuration for every DS64 except for the board ID and the addresses for the various inputs and outputs. And so that information, you can't save that information in JMRI. The information is only saved on the device itself, but what you can do is in JMRI, you can read the settings from one DS64, then change the board ID and write that to a new DS64 and just duplicate those settings. So that's very quick and easy. You're going to program the output addresses too, and so I want to. That's the most difficult part, is getting the actually the output addresses are easy. The input addresses are a little cryptic. So, but I got that figured out. So one of the things, if you're gonna plan a big deployment, say more than 20 or 30 devices on your LocoNet network, it's a good idea to plan your address space, because that way you can tell from the various from the address what type of component you're dealing with. So what I do is I reserved 1 through 99 for turnouts, other BDL 168s, PM 142, all this other type of stuff. I'll never need 100 of those, but I reserved 100 addresses for that. And then the DS64s are in the 100 to 199 space. If you're only doing a few, it doesn't matter. These are the step-by-step instructions for connecting a DS64. We've probably got about 5 minutes, so let me just remind everybody, if we get cut off by Zoom, just rejoin the meeting. We'll give it a couple of minutes for everybody to get back on, and then we'll just continue from wherever we stopped. But basically, so this is a little more detailed than you get from in the actual DIGITRAX instructions. I wrote this out because I have a lot of these, and it got confusing for me. But so some of this I won't go into the hold the button for 10 seconds and everything. That's just straight out of the DIGITRAX stuff, but I included it here just for convenience. But anyway, you're going to connect the DS64 to LocoNet using the LocoNet cable. Then you're going to connect it to the track using the A and B connectors. Those are up here at the top connections. And then you're going to program the board address, and this gives you the detailed instructions on how to configure that. You're going to use a throttle to do that. That's really the only way to do it. All right, so then this continues. What you do then is you assign the output addresses. One of the things I learned preparing for this is that there is a way to do that in JMRI. I haven't figured it out yet. So I do use a throttle for that, and it's fairly simple. I do recommend that you use consecutive addresses to keep it simple. I didn't do that in one case, and it's caused problems every time I go back to deal with that particular DS64. But you do that for the 4 outputs, and those will just show up in JMRI then, and you can document them. I'll show you what that looks like. Then you're going to configure the DS64 inputs. This is where it gets a little bit tricky. We have 2 option switches that we've got to set to closed, and we do that in JMRI like I was talking about before. And that allows us to use all 8 inputs. So then the next thing is this goofy input addressing scheme they came up with, which is basically documented here. I found somebody else ran into this and posted it on some forum somewhere, and so I've documented it. This works, but it took me forever to figure out what was going on with this. So basically what we do is you take your board ID, subtract 1, and multiply it by 8, and then add 1, and that is where your input addressing is going to start. And those addresses will just automatically show up in JMRI once you configure the board ID. And what I do in every case is immediately go into JMRI, document those 8 inputs, where they came from. Even if I'm not using them, I put notes in there to say, okay, as of April 20th, this particular input is not used. And that if I come back to it a year later, I know that I didn't just forget to write something in there. I can actually still use that input. These components are expensive, so you do want to be sure you're exploiting each one of these and using all the inputs. There will be, typically I have more inputs than I need. I'm buying DS64s for the outputs, but you still don't want to waste. This is a screenshot of what that DS64 configuration screen looks like in JMRI. You can see 12 and 13 are checked here. That's what's allowing the all 8 inputs to be used. And then down here, this is, I think that's the switch to make sure that it knows we're using slow motion switch machines and not a solenoid machine. So the next thing is you're going to connect the DS64 to a tortoise. And so basically, this is going to, I'm leaving out the LED part here. All right, we're picking up from where the first session left off. The second section didn't record properly, so I will just narrate this last part of the presentation. There are 4 sets of outputs on the DS64. They're labeled 1R, 1G through 4R, 4G. Each one of those sets of outputs can connect to a tortoise machine and control that machine. You just connect those 2 connections on the DS64 to the outer 2 connections on the tortoise machine. So let's just say we're using 1R and 1G. That has already been configured in the DS64, so we can test that from JMRI. If the tortoise moves, we've got it right. If it's reversed, there's a button in JMRI where we can reverse that connection in software, or of course you can just reconnect the wires in a reversed configuration. This is what that looks like. The 2 output sections are in the middle of the DS64. There's 5 connectors on each of them. We only use 4. The middle one is left out on each of these, at least for stall motors. I've never configured one with a solenoid motor, so I don't know how that works. But this is the screenshot in JMRI where you can label the turnouts. And this is also where you would test where it says unknown, that with the booster turned on, that will allow you to throw the switch from there. And here's the inverted button that I was mentioning earlier. The next thing is to connect the push button. So the DS64, the way we've configured it in this clinic is to allow all 8 of those connections to send an on-off signal to JMRI, sorry. Each sensor has an address, which we covered earlier, and JMRI can be configured to perform a variety of functions once that signal's received. So to connect the 2-button push button, we connect one of those leads to the ground, which is labeled plus COM in the first set of connections on the DS64. It's the middle of those 5. And then we're going to connect the other wire to the first input. The COM connector, I wire that as a bus on the panel because all of the inputs will use that same ground. And then in JMRI, we will put a label on that input and then also configure the route, which I'll get to in a second. Here's just a diagram showing what that connection to the button looks like. And the next thing is to actually connect the LEDs. We left that out for simplicity purposes. I use bicolor red and green LEDs to show status. Those are wired in series with the tortoise on each leg of that circuit, and the polarity is what actually controls whether it's red or green. So if you get it wrong, you just reverse it. It's a little confusing to have these wires going all back and forth to the DS64, the tortoise, and the panel. But then that's why I use termination strips in that connection matrix that keeps everything square. I still get confused, but it makes it easier. This is what that circuit looks like. I think I goofed up by reversing these lights. I think the polarity is reversed in the tortoise, so they should probably be the same, but I just always hook them up, see what happens, and then reverse them if I need to. Configuring the route, we're just going to use a very simple method here, but John Hansky will be giving a clinic either in May or June on some of the really powerful things you can do by using JMRI routes. He brought up, when we were recording this, a method that he uses to allow the dispatcher to prototypically lock out the ability to control switches locally until there's somebody there who needs to use them, and then the dispatcher, by configuring a route, can actually unlock those local switches, allow an operator to use them while they're switching at an industry or something like that, and then lock them back out so that there's no accidents, which is great. And that's not something I'm doing, but it's something that obviously is a lot more realistic. Here's what the screen looks like where you're configuring these. And basically, if you look at the lower section, you can configure the sensor to do whatever you fill in those other boxes. So this is where that's done. It's well documented in the documentation. You also have the ability up here to just select, if you wanted to do multiple turnouts, you can select them out of the table at the top. All we would do in here is basically pick one of those to be toggled, and then configure that for the proper sensor. This is just an example of one of the ones that's already configured on my layout. The last thing to do is to test and make sure you got it right. So I say push the button and listen, because if you hear the tortoise machine move when you press the button, then you probably are real close to having it right, if not already finished. Sometimes you do have to push the button twice because it may already be in the state that JMRI thinks it should be. But 1 or 2 pushes, if the machine runs, you're good. If it's backwards, I mentioned you can fix that with a checkbox in JMRI, or just reverse the wires. Same thing with the lights; they can just be reversed if they're goofed up. If nothing happens, one of the first things that I check, because I've goofed this up and gotten frustrated before, I do most of the configuration with the booster turned off. So you got to remember to turn that back on. The other thing is just loose wires and cold solder joints. I've got little testers that I made so that I can test the Ethernet cables that I'm wiring out to the layout and also off of the panel to make sure there's nothing there. I use a continuity tester also while I'm doing this, just to make sure everything is real solid on a wiring standpoint, because that can be very frustrating to try to troubleshoot. So if you get everything right, your panel will look a little like this, or whatever design that you come up with. A couple of suggestions that were made during the presentation. One was Chuck mentioned that if you're drilling the plexiglass panel, there are drill bits made specifically for drilling into plastic. And if you use those instead of the metal ones that I use, the ones made for metal, then you'll get a lot less burrs and potential cracking of the plexiglass. I've done that before. So that's a great recommendation. And then John had also mentioned that that there's a lot of powerful things that he's doing with those JMRI routes. And so that'll be a topic for next month or the month after, May or June 2020. So thanks again for listening, and we will look forward to seeing you on the next, hopefully in person at one of our clinics, but if not, at the next one that's on Zoom.